So, do you guys see this problem with the years and the ad revenue? Anybody? Yes. I don't know if you've tried this problem out yet. It's in 1.9, so I'm hoping most of you have. But was number 4, did you understand number 4? I'm pretty sure I upgraded everybody's 1.9. And for the most part, number 4 went fine. But I just want to check in and see if anybody's still working on that, if number 4 makes sense. And I had a really good question earlier about why did they pick the class to be 10 to 19.9? Why did they pick that? And there's some work behind the scenes that you will learn in statistics about how wide to make each of these. So what would the next class be, of course? That goes 10 to 19.9. The next class should be
20 to
29.9.
Yeah, so it's sort of like having a consistent scale. You want the width to be the same or else you're being dishonest. And then, so you keep going until you get to about 60 something. It looks like it goes up to 60. So maybe if you get up to 69.9, do you see how that's higher than all these data points? So you keep going. And then the frequency, how frequently does something show up? So these don't show up there. These don't show up. Here we go. There's 2 things that fall between those. Is everybody with me? And then you would count how many data points fall within there. And this is sort of in reverse order a little bit, so that makes it easy going at the beginning. So it looks like there's 4 things. So here, I did a couple of things for you guys. Let me stop there for a minute. And again, like I said, most of you guys have done 1.9, which is good. If you are still working on 1.9, you're a little bit behind. You want to step it up. All right. So just in case, because that was one, I don't know if we specifically talked about the possibility you could have one of these frequency tables with a range of data points like this. But there it is. Oh, something else, a lot of mistakes I saw on this. The way I would make this scale would be 10, 20, 30, and so forth, blah, 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 blah. And then the first, this is probably not going to be the right scale, but the first one would be 2, because there's 2. The next one would be 4. That's crazy. Right? So the height of the bar should be how frequently that showed up, which makes sense. The tallest bar should be the one that occurred the most. The mode. Watch out.
And Jeff, you do that when it comes. You're not making a bar graph based off, like, do you use frequencies to make a bar graph for decimal numbers?
You use frequencies to make a bar graph, sure. You use frequencies to make a histogram, which is what this is that I'm doing right here. Right?
Yeah.
And I think that's later. They ask you to make this. So this is number 4. They just ask for a frequency distribution, which is what this chart is. I think in a later problem, they ask you to make the graph.
Yeah, number 6.
Okay, thank you. So that'll help some of you guys when you go to make corrections. Some of you guys forgot the labels. Some of you guys had some freaky things happening on the scale here. Some of you guys had gaps between these. Remember we talked about that? There shouldn't be any gaps because then that would mean there was an empty class and none of your classes should end up empty. So there shouldn't be any gaps in between these.
Is that for all
histograms.
bar graphs?
Bar graphs.
Like when you're making a bar, that's
bar graphs are for non-numerical data like males, females. So there will be a gap between one category and another because they're not numerical. There's not a normal scale here, right?
Yeah.
Okay. All right, I like it. Any other questions on that? All right, I'm going to clear that. And if there's no questions, we're going to get back into where we left off.
Wait, just a second.
Say again, sorry.
Just a minute. I'm snipping your notes just so I can look at them after. All right?
Okay. You got it?
Yeah, I did.
Okay. Go away. All right. So believe it or not, we are in, where is it at?
What do you
finished
call
section-
this? A histogram? Yeah.
Say it again. What?
So I'm asking because I'm not sure what type of diagram this is called, and you just said you said a word for it. So in order for me to try to histogram.
Histogram. Histogram, yes.
Right.
Like, so we definitely finished 2.1, right? 2.1 is about mean, median, mode, all that kind of stuff. We actually finished 2.2, but I might as well kind of go back over this a little bit. Let's do a few examples here. Did we finish 2.2? Maybe we didn't. Let's see. Oh yeah, well, no, we got about this far. Okay.
Hey Jeff, and how much time do you give for your office hours? Just 30 minutes?
No, it's an hour.
It's an
So
hour.
I have the extra office hours. Is that what you mean?
Yeah.
So I always have half an hour before class starts. So 4 days a week, I'm in there half an hour before class starts. And then 2 days a week, I have an extra hour Tuesdays and Thursdays.
Tuesdays and Thursdays.
Right, and that's in Canvas. It's the extra hours module. That's at the very top of all the modules, right? Okay. You with me?
Yeah, I'm just asking because like everybody learns differently, and as I'm going through the homework, I'm figuring out what is that works for me as when it comes to a learning process. And it's the type of thing where I have to see you do something, but I'm still completely blank. But when I'm searching on my end, I get a better understanding when I get my hands on it. And then that's when the questions have arise.
Yeah.
And that's
yeah,
why
that's
maybe
great.
I should
That's
maybe
how
I
things
should
happen.
meet you in your office works. So,
Sure. Yeah. That's what I got my office hours for. And you don't have to go to office hours, but the people that come to my office hours, I do think they get a decent amount out of it. Because the homework is supposed to generate questions. Obviously, it gives you practice. It's supposed to generate specific questions that you then ask me during class or during office hours. I mean, that's the basic idea of homework.
Yeah, I mean, but at the same time, because you're learning, I feel like, I'm like behind and I know where I'm at, but I'm learning this, and then I'm like, wait, I'm also creating some type of skill on my learning skill, working on that at the same time. So I'm just,
Yeah, sure.
but thank you.
That's why I've got several options for getting help. I like it. So take advantage. So real quick, a couple of things that might show up in some of the homework here. What is the main difference between expressions and equations? If you look really quickly, they look pretty much the same. These are each expressions. So I've got 1, 2, 3, 4 expressions. So those are all algebraic expressions. And then these are all equations. And obviously, the thing that's different about equations is they have
an answer.
Cool.
Okay, I like it. You can actually solve them, most of them, to get a number for the variable that makes it work. But what is the key visual difference? What do these have?
The equal sign.
Equal sign. It's crazy. That might be why we call it an equation, right? I like it. So there might be some things about being careful. Are you working with an expression? If it's an expression, I can maybe simplify it. So if I had this expression here, can I simplify this expression?
Yeah.
Yeah. What can I do?
2m.
Yeah, 7m minus 5m. I can put those together. And that's as far as I can go. I cannot get answers for the M and the Y because I don't have enough information. Here, these kind of things, like
Yeah.
this equation here, we probably maybe could do, right? Maybe. Does somebody know how to solve this equation? Have you guys seen that before?
Subtract 2 by both sides, or both sides by 2. Then divide by 3.
Yeah, so we don't have
So
to
what-
know how to do this at the moment. I just want to show you an example and to see if this teases some memories. An equation, this is how I can get, now I know the value of X that makes this equation true. That's what that means. If X is this number, then this equation is true. But see, this equals 7 is extra information that I don't have for any of these up here. That's why I'm able to do more with this, because they gave me more information. Oh, this is 7. Do I know what 2m plus 2y is? No, I can't do shit with it then, right? So that is the main difference between expressions and equations. Now, a formula is basically an equation, but it means something very specific. It's a certain relationship between things. So for example, this, anybody know what formula this is?
The area of a circle.
Yeah, that's the area of a circle. So it's the relationship between area of a circle and radius of the circle. Let me stop for a minute. So formulas are just equations that are more universal. Like this equation here isn't something that does something forever, right? This one is a definition. It's kind of like it tells me what the area is based on the radius. So let me ask you this. Based on what we talked about last time with inputs and outputs, for this first formula, what is the input? And what would be the output?
Radius.
Yeah, radius would be the input, because if I put something in for R, I can figure out what I get out. So the area would be the output. All right, let me stop for a minute. Okay, and that's just because that's how the equation is currently set up. Anybody know what this equation is for?
Perimeter of a rectangle.
Yeah, if I knew the length and the width. So here, how many inputs do I have in this formula?
2.
Yeah, I've got 2 things I've got to put values in for, and then I'm able to figure out what value comes out. So perimeter would be the output, length and width would be the input. All right, how are we doing so far? I mean, this is not the most exciting thing, but I don't care. Right, just want to make sure that we're all, I don't know if it's been a long time since you took math. I'm hoping some of this is coming back to your brain, how to deal with this stuff. I don't know if anybody remembers what this might be. That might be a big clue. Say again?
What page? Go
Oh,
ahead.
I don't know. I can't see the, oh, it's 169.
Simple
Okay,
interest.
so-
Sorry? I think I heard somebody say it.
Simple interest.
Yeah, it's a simple interest. So it'd be the total amount you have after so many years at such a rate. Anyway, so do you have to know what those are at the moment? No, that's not my point. I just wanted to show you that's what a formula is. It's an equation relating variables that I can use in real life. And it's kind of like a standard equation. Okay. How are we doing out there? So this, sorry, go ahead.
Okay, so I'm looking at how do you know that it means simple interest? PRT, it always means simple interest, or
Yeah, I don't know. And again, that wasn't the point of this, but we had done this before, and I wanted to see if anybody remembered. This is simple interest because it's principal rate time.
Okay.
Did you have to know that? No. I just wanted to see if somebody remembered what that was. Same way you didn't have to know these necessarily, but you probably should. This one is one that we did before, but it's not like something we've worked with a lot. Okay. So this is a formula, but it's not like a standard formula. It's a formula for a very specific situation. If it costs $2 for a cab ride plus $2.50 for each mile, then let me ask you this. If I rode in this cab for 2 miles, how much money would I have to pay? Total.
$7.
Rode in,
750.
sorry? 2 miles.
7. Yeah.
2 miles would be how much for just that?
$5.
$5, right? 2 miles, and it's
Plus
$2.50
two.
per mile, and then I have to pay on top of that just to get in the
$7.
cab. Sorry?
$7.
Yeah, $7. So what did we do? We did 2 plus 2.50 times 2. So you can see why that is the equation. If I went in there for 4 miles, if I was in this cab for 4 miles, how much money would I have to pay? Well, I got to pay 2 no matter what just to get in the door.
$12.
Plus, yeah, 250 times 4 now, because it's for each mile. So it'd be 4 times 250 is 10 plus 2 is 12. I love it. So this is why it makes sense. This is the general, let me erase some of this extra stuff I got here. This is the general formula for that cab. This is for that specific cab. If I know how many miles I've gone, I'm going to multiply it by 250, and I'm going to add the base $2. So that's what this does for me, is it gives me a way to calculate very quickly, well, what if I change the number of miles? I just got to put that in for M. So what's my input?
M.
The miles. I love it. So the number of miles is the input, and the cost is the output. So if I change how long I'm in the cab for how many miles, I'm going to change how much money I've got to pay, which of course makes sense. We all know this, but this is just the math look of things. Okay. So I told you this section was going to be a lot more algebraic. I like it. I like it. And does somebody realize, and again, you don't have to necessarily realize this. Somebody realize what kind of form this thing is in? Is this in some, there's a certain special form this is in at the moment. I don't know if you guys remember. The equation of a line, isn't that mx plus b? So see, you have an amount times a variable plus a constant, an amount times a variable plus a constant. So this is in linear form. Did you have to know everything I just said? No. But I want you to pay attention, mx plus b. So that is in an equation of a line. All right. So I know I'm throwing some extra stuff in that you don't have to know. I think I'm doing a good job of telling you what you don't necessarily have to know at the moment. I just want to point a few things, extra things out. Let me see. Anything else to say on this page? No. I'm going to clear all my chicken scratch. Does anyone have an opposed to that? I'm going to do it. Here it goes. Bye, chicken scratch. All right. So let's see, where's something more interesting? Yeah, here we go. Oh yeah, I love it. All right, well, all right. That's a little bit freakadelic. Let's see, what's a good one? Oh, okay. All right, give me a second. I want to see what they're talking about here. Here we go. Yeah, okay. So let's look at number 5 real quick. All right. So to see how they give me, so that I've got this equation. Don't worry about number 4. I'm going to talk about number 4 after we do number 5, which is kind of funny. So this is the equation for the amount that I have after so many years and so forth. So what if I start with $2,000? Does anyone know what variable that would go in for?
T.
P, that's the principal, right? And then 3% simple interest. What letter would that go in for? Or what would it look like?
R as 0.03.
03.
Yeah, the rate will be 0.03. Let me stop for a minute. Almost every single time you have to throw a percentage into an equation, you're going to make it into the real number. The percentage is what we made up. We made that shit up all day long. This is what 3% really looks like as a number, right? So what does my equation look like now with my new information? I don't know everything. I can't solve for anything yet. Why would I be able to solve for something if I put these values in? How many inputs do I have?
3.
I've got 3, P, R, T. How many inputs do I know?
1.
2, right?
Well,
So take a minute, rewrite what that formula looks like now. Just don't say anything out loud. Just rewrite what the formula looks like now using the information we know. All that means is plug these values in. That's all that means. So wherever you see a P in the formula, what are you going to put there?
2000.
And what am I going to put in place of R?
0.03.
And then T, I don't know. Can you guys still see this down here? What would 2000 times 0.03 be? Have I ever shown you this trick? If I move this over twice, it becomes a whole 3, which means I got to move this back twice to balance things out. 3 times 20 is 60. Or just throw that shit in your calculator. But, you know, we're the humans. We should know better than the calculator. So that is the general equation. If I had 2,000 bucks and I was going to put it into a 3% simple interest account, but I didn't know how many years I wanted to leave it in there for, this is what the equation would look at. Now I can change. What if I put it in for 2 years? What if I put it in for 3 years? And I can see what the output is each time. So this happens quite often. Have you guys, anybody ever watched a show? I think it's still going in a certain format, but it was called Mythbusters. Some of you guys? All right. And every now and again, they would say something, they would say this: we have to control our variables. You have to control 4 variables. So what that means is you try to, so if wind speed might be a variable, you could put it in a wind tunnel and make the wind speed constant so you can control for that. So if I make variables have a certain value for a situation, that's also known as controlling the variables. Now that is a very basic explanation, but that is basically what control for the variables means. Does that really matter? No, I just wanted to throw that out there because it's a phrase that you hear every now and again. That's basically what we're doing right here. So for this account with this much money, that is the equation. What would the input be for this formula? Time. And what's the output? It must be the A, the amount of money, right? So for any time I put in, I'm going to get an amount of money out. That'll be my output. All right. I'm going to clear this, go to the next page. Here we go. Somebody's on the move. Oh, it's tiny. All right, I'm going to clear all this stuff. Go away. All right. Which is fine because now they put our equation here. See, there's our equation again. Let me see. Do I have it set? Okay, good. We already did this, right? So that we did number 6. We did number 6 above. We got this equation. That's the equation we got right there. Now, there's a problem in the homework, and several of you guys, a few of you guys have started this homework. can you see what this is? Just what's called an XY table, but I don't have the letters X and Y, right? XY table. Does that sound familiar to anybody? We were doing it before when we were making scatter plots. We were making ordered pairs. But instead of X, I have time, and instead of Y, I have amount. But it's the same idea. So why did they get 2,000 here? Because what do I know in that row? That first row, what do I know?
Is that's the amount you originally put in?
They
true.
multiplied the t times 0.
Yeah, so what does this mean? Physically, in the real world, oh, somebody's chatting at me. Shit, I can't handle all this technology. Starting value, cool. Why? What does this mean? T0 is the beginning. Yes, the starting value. I love it. So when you play, and mathematically, if you put a 0 in for t, now here's what always kills me is somehow somebody always does this and 60 stays alive. 60 is dead. 0 killed it. It was 0 in the conservatory with a pipe wrench. Dead. So you just get a 2,000. So how would I do this next entry? What does this row tell me to do?
Multiplied by 1 times
Yeah, make
1.
make T1. Now 60 stays alive. So of course, what's that?
2060.
I love it. Kick ass. So notice, well, let me do one more. This is just coming back to something we've done before. We're just talking about it a little bit differently. So to do this one, I would do 2,000 plus 60 times 2, because now I want T to be 2. And 60 times 2 is?
120.
Cool. So I get 2120. Does this look this should look very familiar. Isn't this, what kind of growth is this?
Linear.
Linear.
Yeah, I just keep adding 60, which is what I was saying. This is the equation of a line, isn't it? MX plus B. That's an equation of a line. I like it. So before we were doing linear growth without an equation. We were just adding the same amount. So now you see the shortcut to do this. You just add 60, add 60, add 60. Which kicks ass. All right, maybe. Is every formula linear? Hell no. Right, the minute my t has a squared or a cubed or a square root or something funky happening to it, it's not linear anymore. It's all curvy. It does curvy things. Waha! All right. There's a homework problem just like this. Not with the same formula, but the same idea. So now you know how to attack that bad boy. I'm going to clear this stuff. It's going away. Bye. All right. Well, this is dumb. If we fill this out, then we could just read it. But I erased it, of course. Now, here's the interesting thing. Let's see if they go far enough. How long does it take for the account to reach a value of 2240? I want to do this purely algebraically. Of course I do. I'm a math guy. I don't care. What is this? Which letter, which variable is this related to?
A.
A. So I would put it in place of A. That equals 2,000 plus 60 times T. Right? So if I just subtract 2,000. Now look at this. I'm hoping that this is a little bit familiar to you guys. How to solve an equation. If I subtract 2,000, I really want to make, now look at me. Don't look at the problem, look at me. If I said it grew by 60 bucks and it starts at 2,000 and I said, how long until it reached 2,240? Wouldn't the first step be, well, if it starts at 2,000, it went up by 240. So that's the big 240. You guys with me? Stop. Right? I really want to show you what algebra does for us. Let me say this again. So if it starts at 2,000, I say, how long until it grows to 2240? Well, you go, all right, that means I added $240 because it started at 2,000. And if I keep adding 60 each time, what would I do with 240 and 60 to figure out how long it takes?
Divide.
Divide. And isn't that what's going to happen algebraically right here? I'm going to divide by 60, so I cancel it. So sure enough, I get t equals
4.
4. And if I would have just kept going on this chart, now this is what they really wanted you to do, but I just had to. So you just keep adding 60. That's where I hit 2240. So they just wanted you to look there. I want to show you mathematically what it does for us. All right. So yes, that whole thing I just did is extra. Okay, maybe. But that's me. I just keep trying to bring extra stuff up because I'm crazy. You took my class, you're crazy too. All right, so let me clear this. I'm going to clear this out the way. Gone. All right, and there's some TI stuff in case you have a TI calculator. You could kind of play with that. If you don't, it's not a need. You don't need to do that. And then I just have more examples of plugging values in. Something we've been doing this whole semester, to be honest, plugging values in. All right, so let's take a look at the actual homework, just so you don't freak out about what this could look like. Number one's more of a conceptual problem. Number two, they actually give you the formula. So this is for a certain type of car. Different cars have different stopping distances with different tires and all this kind of stuff. But this is a general formula right here that tell you a little bit about it based on experimental data. It would be interesting to see what kind of car they used, right? But this is just like that problem we did where they give you, where would I put 5? What is, in this formula, what does D mean? What does R mean?
Distance and rate.
Yeah, D is the stopping distance and R is the speed. So in this first row, what is it they tell me?
But at 5 miles per hour, you stop at.
Well, we don't know that yet. So the first row, all it tells me is that 5 is the speed and the speed is R. So I would put 5 in for R. Same thing we just did a minute ago. It's a little more interesting formula because it's got a square on it. So you got to be careful about that. So it's not linear anymore. You're not going to see a constant increase.
Yeah,
Yes.
that's where I'm confused. I tried doing this.
Exponential.
Well, it's I'm glad that I have to do things on my own so I can learn what I'm dealing with, what I don't understand, because just the way I learn. But I know my question when I was doing this problem, D equals R plus 0.05 to the
R squared, yeah.
square. Would you times?
Well, I can't do anything with this right now. There's nothing I could do with this. No like terms, right? But what does this first row tell me that I could use? What is 5? Which variable does 5 relate to?
The variable you're going back to.
So this keeps telling me R is 5, and then this row R is 10. That's another way to look at this. This is speed, which is R. So let me put an R up there. So for this first row, what does the formula look like? What can I put? What can I replace? I can replace which letter with what number?
5 plus.
Yeah, I can
0.0.
replace all the R's with 5. I like it. So 5 plus
0.05
0.05
times 5
squared.
So the first row tells me R is 5. How do I know it tells me R? Because R is the speed and the first row are speeds. I mean the first column. So the first row, it says R is 5. I can then take this formula and replace R with 5. And again, what's the purpose of a formula? It says, if I only knew this shit, I would know this shit. And then the table says, all right, Well, now I know R is 5. All right, sweet. I could throw that in, and then I could figure this out. Of course, you could just throw this in an old calculator, but still. And then whatever the hell that is. Looks like it's going to be, oh, come on, Jeff. 6.75? Sorry. It's too early. That should be 6.25.
Yes.
So what does that mean? If I'm going 5 miles an hour, whatever kind of car they use, it should take me on average 6.625 feet to stop.
Jeff, the question here is, are you always going to time the input is the amount that we're going to use in the output? The input is the speed variable?
In this case, yeah, the speed is the input because
And we're going to time.
distance is
we always-
related to.
Right.
Go ahead. Sorry.
No. I'm the one learning. Go ahead and I'll ask you.
No. It's, all right. Go ahead.
So we're going to times 5 times 0.5, and that's our answer. That's it.
No, it's not what we did. We have to do what this formula says to do. We have to do 5 plus 0.05 times 5 squared. So 5 plus 0.05 times 25. I could throw that in the old calculator.
So we're doing an add, and then we're doing a multiply. We have two different answers that we don't combine, or the answer that we get from the addition, we're going to use that to times. So I guess where I'm.
So again, what never goes away is order operations. Order operations is always there. So what would order operations say I have to do first here? Add or multiply?
It's saying to add 5 plus.
No.
No.
Where's addition in the order operations?
All the way to the bottom.
It's at the ass end of PEMDAS, right?
Yeah.
So I'm going to do that last. So multiplication comes before addition. So if you want to see this
We're going to
all the way down. So what you do is this little 5 plus is just hanging out. 0.05 times 25 is 1.25. So you do multiplication and then you do addition at the end. That's because it's at the end. 6.25 what?
6.25 times to the.
Stop.
Oh.
Units. I'm done with all the calculations, right? I've got this answer. What's the units?
Feet.
Feet. Okay. So I mean, once you've done this, it's not still there, right? I do, because you started saying something about something squared or something. That's done. That's already been done. This is the number I got, and the only thing missing is the units. Yeah. So if I want to do this next one, I would use the exact same formula because that's the formula for the whole thing. But what do I know now in this next row? I know R is 10. So how would I write that? D equals R, but I know R is 10.
D equals 10
Plus 0.05 times R squared. But what's R?
times
R is 10. So let me do this. Let's work with something we all should be very used to working with. All right. So let's say, let me make a new formula, okay? Let me make a simpler formula. Yeah, there's something we all know well.
I mean, I might have to reach out to you tomorrow, first thing in the office hours, just because
Well, just give me a second.
I have a lot of questions already. But like,
Here we go. Sal, give me a minute.
all right,
So let's say that back in the day, Jeff was making $4 an hour, right?
yeah,
Of course, my first job, I was making $3.25 an hour.
Okay.
but gas was also 99 cents a gallon. So, hey, so that helps you round out maybe how old I am. I don't know. So if I made $4 an hour, right?
So you're
How much
like
money?
45?
What's happening?
What's your age? You never told us your age.
No, stop. That doesn't matter. I don't care anymore about that. If I'm making $4 an hour, right? And I work for 3 hours, how much money will I make?
$12.
$12 a day.
$12. Are you with me? Does that make sense? $4 an hour. I work for 3 hours, right? I would make $12. How's everybody doing out there? Does that make sense by itself? That is not a formula. That is just an everyday life thing, right? If you make $4 an hour and you work for 3 hours, you're going to get $12.
Yeah.
Don't worry about tax and all that shit, right? This is
No,
all
I
under the
mean,
table.
yeah.
This is all, they give me cash, right? They give me cash so I don't have to report it. Or, I should, but I don't. So what if I worked for 7 hours? How much money would that be?
$28.
Yeah, 7 times 4. So how would I capture the general relationship between hours worked and money made? Money equals, what do I keep doing whenever I have a new time? What do I do to it to figure out how much money I made?
Multiply by 4.
Multiply by.
So this equation, this formula is mathematically capturing the idea of what I would do if I knew how long I had worked. I would just multiply that by 4. So my input would be time worked and my output would be money made, which makes sense. I'm like, man, I need to make $400. How many hours would that take? I got to figure out what would I put in here to get 400, 100 hours. Holy shit. Okay, maybe. So this, even though it's more complicated, even though this equation, let me take all this extra shit away. Even though that equation is more complicated, is the exact same idea. This describes, if I only knew what R was, I could figure out what D is, because this is the relationship. So that's what this table does. It keeps telling me, well, what if R is 10? Oh, I could plug a 10 in and figure out what that distance would be. What if R is 20? Oh, let me plug a 20 in, because I know how they relate to each other. So that's what a formula does. It tells me how does one variable relate to the other variable. And the variable that has all the shit happening to it is the input. And the variable is just sitting over here waiting is the output. All right, is that better?
You can use that. You can use math like for everything. In math terms, like you can describe certain terms in math terms, like just
yes.
Okay.
This is true. All right. Here we go. Now, of course, once you get this thing filled out, so you just have to use the formula over and over again. You can fill this out. Can you do a shortcut by adding the same amount like we did up earlier? Because this is not, I can't do that because this is not
linear.
Not linear. It's got a square in it. So I can't do that shortcut too bad. Nah. All right. So
Wait,
I'm gonna clear. Yeah.
Wait, just a minute. Thank you.
Wait, I gotta. I'm not even wearing a tie. Oh. Okay, so I'm gonna clear this. And I'm gonna stop that so I can move down. And once you get this filled out, you can answer these questions that come right after it. You can just look back at your table to answer these questions. I like it. Let's see, blah, 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 blah. Yeah, and then these are still related to the previous problem. You're still using the same formula. And then this is just a opinion question. What are some factors that would affect stopping distance? So there are other, I want you to realize, is the speed the only variable that would affect somebody's stopping distance? No, right? Even ignoring the fact that you could have different tires, different cars, you have people with different reaction times. You have people that are sleepy, that are texting, you have whatever. There's so many more variables than this. But this is just kind of controlling, this is just ignoring those variables and saying, if all of that was equal, this is the equation for it. Okay, maybe. So number 7 is just saying what other variables might have to go into an equation to really give a more complete picture. All right, so that's what the homework is going to look like for that section. I want to do a little bit of prep for the next section. So some of you guys have done this already. And this is kind of old. We talked about like terms before. I want you to realize something. Can I add these right here? 1B. Can I add them?
No,
Why not?
because they don't have the T's.
The exponent?
So that's right. So this one is can't be added. Why? Not like terms. So what if it was this instead? Can I do that?
Yes.
Yes. What would this answer be? Negative 12t cubed plus 4t cubed?
It's going to be we know it's going to be a negative number, and we know it's going to be 16.
No. I'm not
Negative
subtracting
8.
anymore. Yeah, negative 8.
Or you're subtracting.
It's negative. So another way to think of this is if I'm 12 foot down in a hole and I climb up 4 feet, how far down am I still? I'm still down 8.
You're still down 8.
Or if I owe somebody $12 and I find 4, I can pay them, but I'm still owing them $8, right? So it's nice to think of a physical situation. But the main idea I wanted to get there was these are like terms now. That's why I'm able to combine them. So what if I had this instead? Can I multiply these?
Yes.
Yes. Multiplication is nowhere near as restrictive as addition, subtraction. And we know that from fractions. Remember that? I only need a common denominator if I'm adding, subtracting. If I'm multiplying, dividing, I don't need that shit because multiplication and division are not as restrictive. So here I can make this negative 12 times 4 is negative 48. And this is a lot like scientific notation, right? Like just adding your powers on your like basis. T cubed times t is what?
2 to the power 4.
I like it. 3 t's times another t is 4 t's. That's crazy. So that's just an example of multiplication not being nearly as restrictive as addition, subtraction. So sort of like down here. These are not like terms, so who gives a shit? I'm multiplying. So I can multiply that stuff together. Okay, enough of that. You guys can do the rest of that. That's part of the homework, of course. And now let's see what time it is. Okay, good. I like it. So let me stop there for a minute. Anybody have any lingering questions on that? Okay.
Tomorrow,
Yes.
your office hours are 8 a.m. and 9 or 8:30 and 9?
Yeah, every day it starts at 8:30, right? So half an hour before class starts. And then tomorrow I've got 12:30 to 1:30, if I remember correctly, is my extra office hours.
Oh, it's after class. Okay.
Yeah, that's for all my classes. So I just put it
All right.
somewhere that works for me.
All
I'm
right.
thinking about changing that up because I'm having like if I have 2 people show up, that's a big day for my
That's a big
extra office hours. Yeah.
Okay.
So I don't necessarily want to do away with them because it is helping those people out.
Yeah.
But and I get my work done too. If nobody shows up, I just sit here and work. So it's not that terrible, I guess.
Okay. Because I'm realizing like well, like there's questions that I have when I'm doing the homework or I'm trying to read on my own, and watching you do things, like it's cool. It's a cool thing to have, as a teacher, and we're learning. but I learned some other way where I have to get my hands. I have to try
Yes.
to figure it out my own, and then that's the
Yes.
way I learn. And then I have to come
Yes.
and ask you.
Yes. Otherwise, I wouldn't assign any homework. I'd just make you sit here and watch me do shit, and
Yeah.
I'd have a lot less to grade. But
Yeah.
that's why there's homework. That's why it's important to keep up with it.
It is because it's crucial. I mean, you can. I mean, it just confuses the hell out of you, like if you're not on track. But yeah,
Yes.
all right. So I'll see you tomorrow, and you have one office hours.
Well, wait a minute. What's happening?
Are we
We're
still
not
have
leaving
class? Oh,
unless
yeah.
you got to go. Of course we
No,
do.
no.
All right.
But do we still have class? We still
Yeah,
have,
dude.
Yeah.
Yes.
Okay. Cool. Great. I thought you were ending the class. I'm like, what the fuck? I'm
Nope.
sorry. What the heck? What the heck? But yeah.
Yeah, don't say hell.
Yes.
Do not
Yeah.
cuss here, damn it. All right?
My apologies. Yeah.
It's fine to cuss, dude. I'm not going to take it personally. All right. So I have no idea why, they're like, it's for South Park. It's for kids. Shut up. I hate books that kind of pander to people, but I can deal with that. I like South Park. It's fine. We've done these kind of things before. This idea of units of measurement. Can somebody give me an idea of a unit of measurement I would use for area? Could be almost anything. It just has the right. There's got to be something about it. So what could I use? Square feet, right? So think about carpet. Square yards, square feet, right? As long as it's something squared. And why does that make sense? Well, let me see. The most basic area formula is like length times width. So if I have a rectangle that is 5 feet by 2 feet, the area would be 5 feet. Jeff, what is that? Times 2 feet. 5 times 2 is 10. Feet times feet is feet squared, right? So mathematically, that just happens automatically. Okay, maybe. Automatically? Sure, why not, Jeff? What about volume? Now, the funny thing is, when you go to buy like Pepsi or something, what volume does it come in? What of Pepsi? How big of a bottle? You could do it.
Liter.
You're gonna go buy liters. So normally you get like a 2 liter bottle, right? So of course this is not American. What the shit, man? We're America. We're not right. So we have all our weird shit that we do. But give me something. What's something else that would be volume? Like well, of course we use gallons, sure. But what if I had a little thing that was
Cubic centimeter.
yeah, cubic centimeters, I like it. So if I had 1 foot by 1 foot by 1 foot, for example, that would be a cubic foot because it's length times width times height. Or cubic centimeters, I love it. Jeff, you could do it. Is that an M? Have you guys ever heard, you guys watch any ER? Sal, give me a minute. You guys watch any ER shows or something where they say, give me 300 cc's of saline, right? cc is cubic centimeter, cc. Just, I don't know if anybody knew that. Somebody out there did, no? But that's good to know. I mean, you hear the cc thing all the time. It's cubic centimeters. So what's up, Sal?
So you're only doing 1 feet to the third power just because you got all sides, height, width, and length being 1 foot.
So watch, let me do another example here real quick. Holy shit. Oh my God. All right, Jeff, don't look at that. There you go, buddy. I can deal with that. It's fine. It's okay. Look, you try to, all right, so say this is 1 foot by 3 feet by 2 feet. What would that volume be?
1 feet and another 1 feet?
1 foot, 3 feet, 2 feet. 1 by 3 by 2.
So you're doing 1 plus 3 feet. You're adding?
Definitely not.
1 times 2
Length
times 3.
times width times height.
6
Say again?
feet.
Somebody just keep saying feet. This is not good.
Square feet.
1 foot. What's 1 foot times 3 feet times 2 feet?
Hey.
What's 1 times 3 times 2?
6.
2.
6. And what's foot times foot times foot?
Foot cube.
Right? Now look at me. Look. What's x times x times x?
X cubed.
X cubed. So what's inch times inch times inch?
Inch cubed.
Inch cubed. That's all. That's it.
Shit.
And I want you to realize if I could just draw better, everybody would have a better day. I know. But give me a second. Let me try this. Hold on. I'm going to clear this out of the way. Anybody still doing stuff with all this business up here? It's going to go away.
Yeah, you can erase that.
All right. Thank you so much. All right, here we go. So let me try something else. Now watch real quick. Let me see if I can do this. Let me really try. Why did I say that out loud? No. All right. Hey, look at that. That's like a gold letter right there. Okay. Now let me kind of add some internal stuff here. This will make it look really neat. Is that cool? Neat. So again, if this is 1 foot, is everybody cool with that? You guys have all seen that symbol before. That means foot, right? This is 1 foot by 3 foot by 2 foot. It's 6 cubic feet. What that really means is if I put in cubic feet, little cubes that are foot by foot by foot, I could fit 6 of them in here. Right? In fact, it would be basically cut that in half. It's really hard to do this with my shitty ass drawing, but oh, there'd be 1 layer with 1, 2, 3, and then the next layer with 1, 2, 3. That would be 6 little cubic feet. So we get cubic feet just because of math. Foot times foot times foot is cubic foot, right? But it also makes sense just visually. If I have little cubes, it's like little ice cubes. I could put 6 ice cubes in here and they would fit. 6 cubic whatever. Now, of course, they're not little. They're freaking cubic feet, but oh well. Woo! So there's almost always a visual aspect to mathematics and a computational aspect to mathematics. And that's really obvious with units. I could just do the math, foot times foot times foot, and I could do a visual, little cubic foot. Yes, somebody?
What would you, so you said there's 2 phrases for math. What would you call this?
Well, I just did both. So there's the visual, like the physical, right? Visual. And then there's just the pure math. So math says foot times foot times foot is cubic foot. But why does that make sense? Because if I had 1 little cubic foot, I could fit 6 of them in here. That's what that means. So that's why it's 6 cubic feet, because it could hold 6 cubic feet. And what is volume supposed to tell you? How much the thing can hold. Right? Sort of like how you buy a car maybe is how much cubic feet or
Yeah, you're right.
Right? How much cubic feet you could fit into the car. Okay.
In the cargo space. Not in
If
the,
you stack people. Exactly, cargo space. Let me clear all that. Okay. So look here. This is kind of, if I would have just kept going, this is really making the deal for me. This is really just hammering it home. How would you get the area of this thing? Well, how long is this side?
fuck.
How long is this side total?
5 inches.
Yeah, 1, 2, 3, 4, 5. And how long is this?
4 inches.
So of course, mathematically, what would you do to get the area?
Multiply.
5 times 4.
Multiply. I love it. So you get 5 inches times 4 inches. So the area looks to be
20.
20. Now, what is a square inch? A square inch is a little square that's an inch by an inch, right? Oh my God, what just happened to me? Inch by an inch. Is everybody cool with that? That's what a square inch means. It's a little square.
You're
that's
under
an
the
inch by an
pictures.
inch. Sorry?
I said you're drawing under the pictures, but I hear you. I can't
Okay.
see it. Yeah.
Oh shit. So how many little square inches do we have? Well, of course I got 1, 2, 3, 4, 5, 6, 20. So that's the visual of how I get 20 square inches. I can actually just count the 20 square inches. Or the mathematical 5 times 4 is 20. Inch times inch is inch square. So they both agree, thank God. I like it. I'm not even sure if I'm answering their questions, and I almost don't care. Yeah, we basically did. I like it. Okay. Oops. All right, last thing for today, I think. I'm going to let us out a little bit early. Oh, beautiful. They got a better picture down here. Look, this is what I was trying to do, and there's no way I could do that shit. I think that almost exactly this problem came up earlier this semester. So this is the same idea. I've got little cubic centimeters. Each one of these is a little cubic centimeter. If I just count how many there are, how many do you get? How many are just on this side facing me? How many little cubic centimeters? Yeah, 4 by 3 is 12. And then how deep is it? It's 2 deep. So how many total would I get?
24.
24. Yeah, I've got one sheet here and another sheet on the back. So I've got 24 cubic centimeters. So what's the mathematical way to do this? I just get out of there. I sort of did it on the way there, but you can see why. There's 4 on this side, 2 deep, and then 3 up. 4 times 2 times 3.
24.
24 is crazy. Yeah, so I know we did something like that earlier this semester. Oh, and of course, the formula for volume, I gave you that already. But you can see why it's length times. I really hope you guys can see that, because the quickest way to count these is to go, well, there's 4 by 3. So there's 12 in this front sheet, right? And then the back sheet, there must be another 12. So it's 4 times 3 times 2. So of course it's length times width times height. Of course that's the formula. Okay. What do you guys think? I think that's enough for today, huh?
Yeah.
Yeah. I thought that would be a yes vote. All
Okay.
right, so I'll let you guys out a little early. I'll let myself out a little early for my birthday. Yay, Jeff. That's
Happy
how I
birthday,
really
Jeff.
celebrate big. All right, guys. So let me
Happy birthday, Jeff. See you tomorrow.
want to hang out. You have any questions? Thanks, Sal.
Happy birthday, bye.
Thank you.
Yeah, happy birthday.
Birthday. Bye.
Happy birthday.
There you go. There you go. Is everybody else out there okay? I don't see any questions. I'm going to head out. Bye, everybody.